Here is a shape on a grid. Complete the design so that it is symmetrical about the mirror line. So we need to have the same reflected on both sides, and the way to do that is to dot the corners. So these 2 points are on the mirror line, so they'll be on the mirror line when we reflect the shape as well. To get to this corner, we go 3 squares to the right, so from the mirror line we can go 3 squares to the left. Here we go 2 squares right, so we can go 2 squares left, and here we go 2 squares right, so we go 2 squares to the left. And then all we need to do is join up our points, and we've reflected the shape so that it's symmetrical about the mirror line. Stefan completes this calculation. 95 minus 67 equals 28. Write an addition calculation he could use to check his answer. Well, subtraction problems can be read backwards as addition problems. So if we add 28 and 67, we should get 95. And of course, with addition, we can add in any order, so we could also have 67 plus 28. On the line below, mark the point that is 6.7 centimeters from A. So we can take our ruler and make sure that we have 0 on the ruler lined up so that it's on point A. Then 6.7 centimeters is 6 centimeters and then another 7 millimeters. So we have 6 centimeters here, and then we can count 7 lines and so draw our arrow here. So that's 6.7 centimeters from A. These diagrams show 3 equivalent fractions. Write the missing values. Well, we could work this out even if we didn't have the diagrams, because we know that we can use multiplication to find equivalent fractions. So first, we need an equivalent fraction to 3/4, which has a numerator of 9. 3 times 3 is 9, so if we do the same to the denominator, 4 times 3 is 12. And that makes sense because we can see that in this diagram we have 9 pieces shaded and 12 pieces altogether. Then we need an equivalent fraction with a denominator of 24. So 12 times 2 is 24, 9 times 2 is 18. And we can see that in the diagram we have 18 pieces that are shaded and 24 pieces altogether. Here are the temperatures in 4 cities at midnight and at midday. At midnight, how many degrees colder was Paris than Rome? So we can see that at midnight is this column here, so we can find Paris and Rome. And we can see that the temperature in Paris was -4 and the temperature in Rome was 3. So from -4 we can add 4 to get to 0 and then add another 3 to get to 3. So to get from -4 to 3 we need to add 7 altogether, because if we add 4 and then 3, that's the same as adding 7. So that means -4 degrees, so the temperature in Paris is 7 degrees colder than 3 degrees, so the temperature in Rome. Now, which city was 6 degrees colder at midnight than at midday? Well, that's Oslo, because if we look at Oslo, we can see that it was -13 at midnight and -7 at midday. And that's a difference of 6 degrees, because to get from -13 to -7 on a number line, we need to add 6. We can see that with Paris we have a difference of only 2 degrees, with Rome a difference of 7 degrees, and with Warsaw, because we have -6 and +2, that will be a difference of 8 degrees. So the city with a difference of 6 degrees, so 6 degrees colder at midnight than at midday, is Oslo. The numbers in this sequence decrease by the same amount each time. So we have 303,604, 302,604, 301,604, and 300,604. So we can see that the numbers are decreasing by 1,000 each time. So that means the next number will be 299,604. So because it's decreasing by 1,000, that means the hundreds, tens, and ones digits always stay the same. So if we ignore those, we have 303, 302, 301, 300. So next we have 299. And then the 604, of course, always stays the same. Tick the two numbers that are equivalent to 1/4. So we have some decimals and some fractions. So let's see whether 1/4 is equivalent to 25 hundredths. Remember, we use multiplication to find equivalent fractions, and 4 times 25 is 100. So if we do the same to the numerator, 1 times 25 is 25, so 25 hundredths is equivalent to 1/4. And because we know that 1/4 is the same as 25 hundredths, we know that it's also the same as 0.25, because with decimals, the second digit after the decimal point is the hundredths digit. So because we have 25 hundredths, we have two digits after the decimal point, because the second digit tells us how many hundredths we have. And because we can only have one digit in each place value, the 2 gets pushed over into the tenths. So we don't have 0.75, because that's equivalent to 3/4, not to 1/4. And 0.5 is the same as 1/2, or the same as 2/4, but not the same as 1/4. And 2/5 is not equivalent, because to find equivalent fractions, we can use multiplication like we've done here, or division, but we can't use addition. We can't say 1 plus 1 is 2, 4 plus 1 is 5, so they're the same. That's wrong, because to find equivalent fractions, we need multiplication or division, not addition. Ken buys 3 large boxes and 2 small boxes of chocolates. Each large box has 48 chocolates. Each small box has 24 chocolates. How many chocolates did Ken buy altogether? So we know that a large box has 48, and he buys 3 of those. So we can draw 3 boxes with 48 written inside. And each small box has 24, and he buys 2 of those. So that's 2 boxes of 24. So to find the total of 3 boxes of 48, we can multiply 48 by 3, and that gives us 144. Now, to find the total in 2 boxes of 24, we can multiply 24 by 2, so that's 48 in the small boxes. So to find how many chocolates altogether, we can add the total number of chocolates in the large boxes and the total number in the small boxes. So 144 plus 48 gives us 192. The list below shows the years in which the Cricket World Cup was held since 1992. Adam says the Cricket World Cup has been held every 4 years since 1992. Adam is not correct. Explain how you know. So let's look at the years. First we have 1992 and then 1996. So that's 4 years later, because 1992 plus 4 is 1996. But next we have the year 1999, and that's only 3 years later, not 4 years later. So because 1996 plus 4 years should take us to the year 2000, that means that the next Cricket World Cup should have been in 2000, not in 1999, if it was held every 4 years. So Adam is wrong, because the next Cricket World Cup after 1996 was in 1999, not in 2000. We have greater than, equal to, and less than. Write the correct symbol in each box to make the statements correct. So first, on this side, we have 11 times 12, so that's 132. And on this side, we have 15 times 10, so that's 150. Because to multiply a whole number by 10, we can just put a 0 on the end. So because 132 is less than 150, that means 11 times 12 is less than 15 times 10. Now here we have 90 divided by 30. So when we have a division problem with end zeros, we can cancel our end zeros, and 9 divided by 3 is 3. Now we have 60 divided by 20, so that's the same as 6 divided by 2, which is also 3. So that means in this box we need an equal sign because we have the same value on both sides. Now 120 divided by 4 is 30 because 12 divided by 4 is 3, and if we have an end zero in our dividend, we need an end zero in our answer. And 160 divided by 8 is 20. So because 30 is greater than 20, we need a greater than sign. And finally, 30 times 8 is 240, because 3 times 8 is 24, and we need our end zero. And then 100 times 10 is 1000, because to multiply a whole number by 10, we can put a 0 on the end. So 240 is less than 1000, so we need the symbol for less than. Here is a drawing of a 3D shape. Complete the table. So first we need to find the number of faces. And with 3D shapes, the faces are the flat bits. So we have a square face at the bottom or base of our shape. We have a square face at the top, but we also have 4 faces round the middle, joining the edge of the square at the base to the edge of the square at the top. So because we have 1 face at the bottom, 1 at the top, and then 4 round the middle, that's 6 faces altogether. Now we need the number of vertices. So the vertices are the corners or the pointy bits. So we have 4 vertices in our base because that's the corners of the square, but we also have another 4 vertices at the top because we have the corners of our square at the top as well. So that's 4 vertices at the bottom, 4 at the top, so 8 vertices altogether. And now we need the number of edges. So the edges connect different faces. So we have 4 edges in our square at the bottom. Then we have 4 edges around the middle, connecting the corner of the square at the base to the corner of the square at the top. So we have that for all of our corners round the middle. So that's another 4. And then we also have 4 edges for our square at the top. So that's 4 at the bottom, 4 around the middle, and 4 at the top. So that's 12 edges altogether. Here is a shape on a grid. The shape is translated so that point A moves to 7, 8. Draw the shape in its new position. So translated just means moved, and point A has been moved so that it has the coordinates 7, 8. So remember, with coordinates, the first number is the x-coordinate. So we can find 7 on our x-axis, and we know that point A is now going to be moved in line with this point here. And the y-coordinate is 8. So if we find where the y-coordinate is 8, on the line where the x-coordinate is 7, we get to this point here. So if we go down, we get to 7. If we go across, we get to 8. So that's the coordinates 7, 8. So now we can draw our shape. We can have 2 squares to the left to draw this line at the top. Then we can see that we go 5 squares down, so we can go 5 squares down. Then for this point here, we go across 1 and up 2, so we can go across 1 and up 2 and draw a line to this point. Then we go down 2 and across 1, so we can go down 2 and across 1 and draw a line to this point, and then we can draw a line back to our starting point, and we've translated our shape. Now the way to check that we've got this right is to see that from point A to the same point on our translated shape, we go up 3 and then 4 to the right. So we can check our other points by going up 3, 4 to the right, and then we should get to the same point on our translated shape. So from this point, if we go up 3 and 4 to the right, we get to the same point. From here, we can go up 3 and 4 to the right, and then to check our last point again, we can go up 3 and 4 to the right, and we get to the same point on our translated shape. So we know that we've drawn the new shape or the translated shape correctly. Circle the improper fraction that is equivalent to 6 7/8. So improper fractions are fractions which have a larger numerator than denominator, and we have 6 7/8, so that's a mixed number. Now to change a mixed number to an improper fraction, we can multiply the whole number by the denominator and then add the numerator. So 6 times 8 is 48, and 48 plus 7 is 55. So we need the fraction which has a numerator of 55, and then the denominator stays the same, so we have 8 as our denominator. We have 6/5, 3/5, and 3/4, and we need to write these fractions in order, starting with the smallest. So we have 2 fractions with a denominator of 5, and 1 fraction with a denominator of 4. And one way to compare fractions is to make the denominators the same by finding equivalent fractions. Now 20 is in both the 5 and the 4 times table, so we can find equivalent fractions for 6/5, 3/5, and 3/4, which have a denominator of 20. So 5 times 4 is 20, 6 times 4 is 24, 5 times 4 is 20, 3 times 4 is 12, 4 times 5 is 20, 3 times 5 is 15. So now we can see that 3/5 is our smallest fraction because that's equivalent to 12/20. Then we have 3/4 equivalent to 15/20, and our largest fraction is 6/5 because that's equivalent to 24/20. But in fact, for this question, we could have found our answer without finding equivalent fractions. We know that 6/5 has to be our largest fraction because that's an improper fraction. It has a larger numerator than denominator, so that means the fraction has a value of more than 1 whole. But both of our other fractions are proper fractions, so fractions with a smaller numerator than denominator, so these fractions will be less than 1 whole. And then, with 3/5 and 3/4, we know that 3/5 must be smaller because we have the same numerator, and when we have the same numerator, we can compare fractions just by looking at the denominator. But we need to remember that the larger the denominator, the smaller the fraction. And that's because each part has been split into more pieces, so each piece is smaller. A box contains trays of melons. There are 15 melons in a tray. There are 3 trays in a box. A supermarket sells 40 boxes of melons. How many melons does the supermarket sell? So we know that they sell 40 boxes, but we don't know how many melons are in a box. But we do know that there are 15 melons in a tray and 3 trays in a box. So to find the number of melons in a box, we can multiply 15 by 3, and that gives us 45. So there are 45 melons in one box, and the supermarket sells 40 boxes. So to find how many melons, we need to multiply 45 by 40. The way I would do that is first multiply 45 by 4, and then to multiply by 40, we can just put a 0 on the end. So because 45 times 4 is 180, 45 times 40 will be 1,800. So that's the number of melons that the supermarket sells. Adam wants to use a mental method to calculate 182 minus 97. He starts from 182. Here are some methods that Adam could use. Tick the methods that are correct. So could he add 3, then subtract 90? Well, that wouldn't be the same as subtracting 97, because that only subtracts 87. If he adds 3 and then takes 90 away, that's the same as taking 87 away, not taking 97 away. Could he subtract 100, then add 3? Well, he could do that, because if he subtracts 100, then he subtracted 3 too many, because 100 is 3 more than 97. But then, when he subtracted 100, he could adjust by adding 3. He could also subtract 7 and then subtract 90, because if you subtract the 1s and then the 10s, you've subtracted the number. So subtracting 7 and then 90 means that we've subtracted 97 altogether. But you couldn't subtract 3 and then subtract 100, because that would be subtracting 103 altogether, and we only want to subtract 97. Now the other way to work out which of these work is just to work out the answer to 182 minus 97, and then work out 182 plus 3 minus 90, 182 minus 100 plus 3, and so on, and see which of these gives the same answer. There are 28 pupils in a class. The teacher has 8 litres of orange juice. She pours 225 millilitres of orange juice for every pupil. How much orange juice is left over? So 8 litres is the same as 8,000 millilitres, because there are 1,000 millilitres in a litre. So we need to know how much juice she has poured so that we can work out how much is left over. So there are 28 pupils and they each get 225 millilitres. So we can work out 225 times 28, and that gives us 6,300. So we know that the teacher started with 8,000 and poured out 6,300, and we need to know how much is left. So we can subtract 6,300 from 8,000, and that gives us 1,700. So 1,700 millilitres, or 1.7 litres of orange juice is left over. Last year, Jacob went to 4 concerts. 3 of his tickets cost £5 each. The other ticket cost £7. what is the mean cost of the tickets? So to find the mean or the average, we add up the total amount and divide by the number of things. So we know that 3 tickets cost £5 and the other ticket cost £7, so that's £22 altogether. So £22 is the total cost on 4 tickets. So to find the mean cost, we need to divide £22 by 4, because he bought 4 tickets, or went to 4 concerts. So we can copy up the decimal point. 22 divided by 4 is 5 remainder 2, 20 divided by 4 is 5, and 0 divided by 4 is 0. So that means the mean cost of the tickets is £5.50. Layla wants to estimate the answer to this calculation. So we have 3 9/10 minus 2 1/8 plus 1 4/5. Tick the calculation below that is the best estimate. So here we need to round fractions or mixed numbers to the nearest whole number. So first we have 3 9/10, and 9/10 is more than 1/2 because 1/2 would be 5/10, so that means that we can round up to the next whole number. So 3 9/10 rounds to 4. Now we have 2 1/8, and 1/8 is less than a half because a half would be 4/8. So that means we can round down, so 2 1/8 is between the whole numbers 2 and 3, but it's closer to 2 than it is to 3, so we can round down. And now we have 1 4/5, but 4/5 is more than 1/2, so we can round up to the next whole number, so round up to 2. So that means when we round our fractions to the nearest whole number, we have 4 minus 2 plus 2. So we can tick this estimate here. The length of an alligator can be estimated by measuring the distance from its eyes to its nose, then multiplying that distance by 12. What is the difference in the estimated lengths of these 2 alligators? So for the first alligator, the distance from its eyes to its nose is 17.5. So to estimate the length of this alligator, we can multiply that distance, multiply 17.5 by 12. So we copy down the decimal point, and then we can see that 17.5 times 12 is 210.0. So if we have a 0.0 on the end, we have a whole number, so that's 210 centimeters. So now let's estimate the length of this alligator here. We can see the distance from its eyes to its nose is 15, so we can estimate the length by multiplying 15 by 12, and that gives us 180 centimeters. Now the question asks us what is the difference, and to find the difference we subtract. So we can work out 210 minus 180. So that gives us a difference of 30 centimeters. Amina is making designs with 2 different shapes. She gives each shape a value. Calculate the value of each shape. So here we can see that we have 2 hexagons and 3 cone shapes, and the total value is 147. And here we have 1 hexagon and 3 cone shapes, and the total value is 111. So we can see that all that's different is that this shape here, or this design here, has 1 extra hexagon. So we can find the difference with the total values, and that will give us the value of a hexagon. So 147 minus 111 is 36. So that means the hexagons must have a value of 36, because the only extra shape that this design uses is one extra hexagon, and that makes the total value an extra 36. So we know that the hexagons have a value of 36, and from that we can work out the value of the cones. So if we take this shape here, we know that 36 plus the 3 cones has a total value of 111. So if we subtract 36 from 111, that gives us 75. So we know that 36 plus 75 is 111, so the 3 cones must have a combined value of 75. But if 3 cones have a value of 75, we can find the value of one cone by dividing 75 by 3. So that gives us 25 as the value of a cone. And then we can check 25 plus 25 plus 25 is 75, plus 36 is 111. And we could also check that 25 plus 25 plus 25 is 75, plus 36 is 111, plus another 36 is 147. This is the net of a cube. What is the volume of the cube? So to find the volume of a cube, we multiply the length of the cube by itself and then by itself again. But how can we work out the length of the cube? Well, we know that the total length is 20, and that's the same as the length of 4 faces. So if 4 faces have a total length of 20, we can find the length of one face, so find the length of the cube by dividing 20 by 4, and that gives us 5 centimeters. So to find the volume, we can multiply the length of a cube by itself and then by itself again. So that's 125 centimeters cubed, because 5 times 5 is 25, and 25 times 5 is 125. The length of a day on Earth is 24 hours. The length of a day on Mercury is 58 2/3 times the length of a day on Earth. What is the length of a day on Mercury in hours? So we need to work out 24 times 58 2/3, because that's how many times larger a day is on Mercury than on Earth. So we need to multiply a mixed number by a whole number, and there are different ways to do that. We could multiply 58 by 24, then multiply 2/3 by 24, and then add up our answers. Or we could change 58 2/3 into an improper fraction. So to do that, we multiply the whole number by the denominator, and 58 times 3 is 174, plus 2 is 176. So we can write 58 2/3 as 176 over 3, and we're multiplying that by 24. Now remember, when we multiply a fraction by a whole number, we only multiply the numerator and the denominator stays the same. Now there is a possible shortcut here, but I'll come back to that in a moment. For now, we could work out 176 times 24, so we could use long multiplication, and that would give us 4,224. But the denominator stays the same, so to find the number of hours, we can divide 4,224 by the denominator, so by 3, and that gives us 1,408. So that's the number of hours of the length of a day on Mercury. Now, I said there was a shortcut here, and what we could do, because 24 is a multiple of 3, we could just divide 24 by 3, so that's 8, and then Instead of multiplying by 24 and then dividing by 3, we could just multiply 176 by 8, and that would give us the same answer.